Today we're looking at radian measures and angles of rotation. So you're going to go to that link in Google Classroom and fill out this first page. When you're done, you can unpause the video and come back. So it says we're going to change the size of the circle of the radius using this R value right here that changes your radius length. And we're also going to change this other value to change the arc length. And we're going to compare the two. So if I make this a little bit bigger, so when we have a radius of 1 and I make, remember this red part here, that's my arc length. So if I make that equal to 1, and I can use my right and left arrows on your keyboard to kind of make it a little bit better. So you notice when we have a radius of 1 and the arc length is also 1, the angle is 57.3 degrees. So let's change the radius and arc length to 1.2 and 1.2. Still stays the same angle. And it doesn't matter what we change our radius and our arc length to. You see that angle has not changed no matter how big or how small our circle is. It's 57.3 degrees. So you should have filled in this table already. So let's going to go down here. So again, you would put your radius, whatever it was. So we had a radius of 1 and an arc length of 1, and we got 57.3 degrees. And it didn't matter what we chose, 2 to 57.3 degrees, 2.3, 2.3, 57.3 degrees. So it didn't matter what the radius and the arc length were. If they were equal, we noticed that they were always going to give us the same value for the angle. So what do you notice about the size of the angle? They are the same. What can you conclude about the angle from the information in this table, given that the radius changed each time? So it didn't matter what the radius was. So when the arc length is equal to the radius length, the angle was the same. So the angle that creates an arc length equal to the radius is called 1 radian, and 1 radian is about 57.3 degrees. So a radian is a unit of angle measure based on arc length. 1 radian is defined as the measure of the angle formed by bending the length of the radius around the arc of a circle. So let's go ahead and see this. So right now we have a radius of 1, and if I take this radius and bend it around the circle, so that gives me 1 radius around my circle. And now if I do it again, that would be 2 radii. We say radii for plural for radius. So now I have 2 radii. And that's 3 radii around my circle. And notice if I do 3 and a little bit more, 3.15, and I'm a little over, 3.14. Do you recognize that? Looks like 3.14 is pi for half our circle. And if I keep going, so that's then 4, 5, 6. So it took us 6 radii to go all the way around the circle and a little bit more. And you'll notice that we have 6.28. Half the circle was 3.14. So another 3.14 around the circle gives us 6.28. So if this is pi and this is then another pi, we get 2 pi all the way around our circle. So then you say, well, what if the radius was larger? So if our radius was larger, you can see that it doesn't matter because it still takes, no matter what, 6 radii and a little bit more to go around the circle, no matter how big or how small your circle is, which is why we get a radian measure. So it takes 6.28 radians or 2 pi to make a complete circle. So then that tells us then, recall that the circumference of a circle is 2 pi r. So if r was 1, Therefore, all the way around your circle would be 360 degrees, or 2 pi times 1, which is 2 pi radians. So then if we took half of that, then we get pi radians. And so really, when we use this equation, we have 2 pi radians equals 360 degrees. It's very important that you always label a degree with a degree symbol. If it doesn't have a degree symbol, then we assume it's a radian measure. So let's say I wanted to figure out what 1 radian was. If I wanted to figure out 1 radian, I would divide both sides by 2 pi. So 1 radian is equal to 360 over 2, which is 180 over pi degrees, right? And if vice versa, if we had 2 pi equals 360 degrees and we want to figure out 1 degree, I divide by 360 and we get 2 pi over 360, which is pi over 180 equals 1 degree. So pi over 180 radians equals 1 degree. So that's where we get our conversions from. So converting to degrees to radians. So to do this, you take the degree and you multiply it by pi over 180, because 1 degree is pi over 180 radians. And vice versa, to convert radians to degrees, you multiply the radians by 180 over pi, because 1 radian equals 180 over pi degrees. So then which one's larger? So this means that, of course, we just showed in the front page of this that 1 radian is larger than a degree, right? Because 1 radian is 180 divided by pi. And what do you notice? 57.3 degrees, which is what we did on our front page. So that is where the is this conversion and everything is coming from, and why we got those same measures. So let's go ahead and convert each measure to radians. So if I want to convert this, we have 30 degrees. So we want to convert this to radians. So we have to multiply this by pi over 180. When we do that, we then get 30 pi over 180. And every time you have a radian measure, you want to leave pi in your answer, and also in simplest fraction form or reduced fraction form. So 30 over 180 is 3 over 18, and 3 over 18 reduces into pi over 6. So a negative 150, multiply this by pi over 180. So when we do that, we get negative 150 pi over 180. So again, you can cross out the zeros there. 15 negative over 18 would be negative 5 pi over 6 when you reduce. Even if you have a hard time seeing that, you can, I guess, if you need to, use your calculator, but I would try to do it without your calculator. But if you need to, use your calculator and just do the problems without the pi and then add it back in, you could. So if I did negative 150 divided by 180 and hit the math fraction key, you can see you get negative 5 over 6, but you just have to put the pi back in. So 330 times pi over 180 gives me 330 pi over 180, and you could do this again in your calculator, or 33 over 18, you're taking out 3 from both to get 11 pi over 6. So those are our radian measures. Now, if we want to convert radians to degrees, we're going to now, instead of multiplying by pi over 180, we multiply by 180 over pi. So for this one, the pi's are going to cancel out, and you'd be left with 180 over 10, which of course just equals 18 degrees. Now for converting to degrees, it's okay to have decimals in your answer. We can just round to the nearest tenth of a degree is fine if it does give us a decimal. So 4 pi over 3 times 180 over pi. Again, the pi's cancel out. And then you're just multiplying 4 times 180. And then dividing that answer by 3. And again, if you can't do this in your head, you can always use your calculator to help if needed, but I really try to do without your calculator. 4 times 180, enter, and then I would divide it by 3, which gives us 240 degrees. And then over here, same idea, multiply this by 180 over pi, so the pi's cancel out. So this would give us, if you multiply this out or use your calculator, negative 168 degrees. So again, if you need to do negative 14 times 180, divide that by 15. All right, so that's how you convert from degrees to radians or radians to degrees. Now we're going to talk about angles in standard form, which is also called standard position. So an angle in the coordinate plane is in standard form or position when the vertex is on, or you can say at the origin, and one ray lies on the positive x-axis. So this is right here. So an angle in standard position is said to lie in the quadrant in which the terminal side is located. So we have our different quadrants. So I'm just going to come down here. So this, of course, is going to be quadrant 1, quadrant 2, quadrant 3, and quadrant 4 is how we name the quadrants. And the ray on the x-axis is called the initial or starting side. So this is the initial ray or starting side. And the other ray where you stop is called the terminal side or the ending side. We have different ways to measure angles in standard position. One way is counterclockwise and the other way is clockwise. So if we have a counterclockwise rotation, notice that follows the way the quadrants go. So this is a positive angle measure. Clockwise results in a negative angle measure. And one full revolution we know is 360 degrees or 2 pi radians. So here's a picture of the positive angle and the negative angle. So when we're doing degrees around our circle, we would have 0 degrees. Up here would be half or a fourth of a circle or 90 degrees. Half of the circle is 180 degrees. And then 270 degrees, we add 90 to that. And then another 90 would give us back around 360 degrees. Well, just like we can measure these in degrees, we can also do this in radian measures by converting. Well, let's think about our radian measure. So I'm going to use the positive angle over here. We started off with 0, and then up here, remember that, well, I guess halfway around the circle is pi, because all the way around the circle is 2 pi. So if we take pi and we half that again, so 90 degrees would be pi over 2 radians. So 0 to pi over 2, another pi over 2 is pi. Add another pi over 2 to pi, and you get 3 pi over 2 is the conversion for 270 degrees, and all the way around is 2 pi. Now, we can also do this in the negative direction as well, which we'll do in some of the examples. So let's just go ahead and look here. Drawing angles. Sketch an angle with the given measures in standard position. Determine the quadrant in which the terminal side lies. So we have 220 degrees. So 220 degrees, we know it's going to be past 180. So 0 degrees, 90 degrees, 180 degrees, 270 degrees. So 220 degrees would be somewhere about in here. And we're starting at the positive x-axis, and we're rotating around to where we ended. Yes, you do need to draw that arrow to denote which direction you're moving, because we don't know if it's a positive or negative angle unless we do that. So we can see that this then is in quadrant 3 because that's where the terminal side ends, and we moved counterclockwise direction. So the next one we have is 67 degrees. So 67 degrees would be somewhere up here. And then our angle would start at the positive x-axis and would go in the counterclockwise direction because, again, it's a positive angle. And this is in quadrant 1. Then the next one we have is negative 25 degrees. So you can also go the negative direction. If I start here at 0 and go this way, this would be negative 90, negative 180 degrees, negative 270 degrees, and all the way back around would be negative 360 degrees. So negative 25 degrees, of course, would be down here and go from the x-axis now in the clockwise direction, and this would be in quadrant 4. Next, we have 156 degrees. So 156 degrees, if this is 0 and this is 180 degrees, of course, would be in quadrant 2. So this is going to end here. And we start at the x-axis and go counterclockwise. And when we do that, we land in quadrant 2. So usually it's easy for students to draw the angles in standard position when it comes to degrees, but let's go ahead and practice what we are learning, which is radians. So now we're going to do the same thing, but using radian measures. So let's go ahead and look at pi over 15. So if we know this starts at 0 radians, and again, we know that halfway around is pi and all the way around is 2 pi. So we said half of that, 90 degrees, is pi over 2, and down here was 3 pi over 2. So pi over 15, I know is going to be in quadrant 1, but if you are unsure, you can always multiply this by 180 over pi. Your pi's would end up, of course, canceling out here. Then you have 180 divided by 15, which is equal to 12 degrees. So again, quadrant 1. Another way you could do this is you could look at the decimal. So if I look at the decimals, I know that if I do pi divided by 15, I get 0.209. And look at pi over 2. Pi over 2 is equal to 1.57. We know pi is 3.14. And so then if you add another 1.57 to 3.14, that would give you 3 pi over 2, or if it helps you just to type it all out, 3 pi over 2 is 4.17. And then add another 1.57, and you would get 6.28, like we said, for the circle. So lots of different ways of looking at how to get this. So we're starting here, going in this direction. So this is in quadrant 1, and we are going in the counterclockwise direction because it's a positive angle measure. So looking at the next one, 4 pi over 5, I know it's going to be in quadrant 2. And if you're unsure, multiply this by 180 over pi. So if we cancel out the pi's, we get 4 times 180 divided by 5. And again, if you have a hard time with this, you could always resort to your calculator. 4 times 180, enter, divide that by 5. And notice we get, whoopsies, I don't know what I did there. Notice then we would get, this is equal to 144 degrees. Or if I look at the decimal, like we did in the last one, we could just plug it in as 4 pi divided by 5, and notice we get 2.51, which is less than pi, but greater than pi over 2. So 144 would be somewhere in here. Oops, that's not a very straight line. And that would be our angle drawn in standard position. So this is in quadrant 2, and we went counterclockwise. Why don't you pause the video and see if you can do 3 and 4 on your own. When you're done, you can pause to check your work. So looking at question number 3, this one I know is in quadrant 3. And so if I multiply this by 180 over pi, the pi's are going to cancel out. And this would give us about 205.7 degrees. It's not quite the nicest number, but that tells me this is going to be in quadrant 3. So we would be somewhere in here. And that's my angle drawn in standard position. We went the counterclockwise direction, and this is in quadrant 3. Negative pi over 12 is, of course, then pi over 12 is going to be would be in quadrant 1. So this is negative, so it's going to be in quadrant 4 down here. Again, if you need to multiply this by 180 over pi to figure out that's negative 15 degrees, you can. So this is in quadrant 4. It's negative angle measurement. So it was this way, and we went the clockwise direction. So that's how you draw the angles in standard position for degrees and radians. So it can be helpful to know some of the frequently encountered angles in one rotation of a circle. Multiples of 30, 45, 60, and 90 angles are commonly encountered in many trigonometric applications. Becoming familiar with these angles and understanding how they relate to one another is going to be very useful when we study the properties associated with them. So we're going to convert each degree measure to a radian measure. So if you look, you'll notice that we did the special angles around the circle. So 30 degrees, add another 30 and you get 60, add another 30, you get 90, add another 30, 120, 150, 180, 210, 240, 270, etc. around a circle. And you can do the same thing with 45 degrees. 45 plus 45 is 90, plus another 45 is 135, 180, 225, 315. So go ahead and pause the video and just convert each of these into a radian measure by, again, multiplying 30 degrees times pi over 180. And we did this earlier, so 3 over 18 is pi over 6. When you're done, unpause the video and check your work, and we'll talk about some tricks. So if this is pi over 6, just like you can count with 30 around your circle, so if this is 30 degrees and another 30 degrees is 60 degrees, well, you can do the same thing with radians. Pi over 6 plus pi over 6 is 2 pi over 6 when you have a common denominator. So this would be 2 pi over 6, but of course that reduces, so I wouldn't actually write 2 pi over 6. I would write that this is equal to pi over 3. So you should have gotten pi over 3 for that one. Well, what if I take that 2 pi over 6 and add another pi over 6 to that? I get 3 pi over 6. So if this is 3 pi over 6, well, we don't want to leave our answer like that. We would want to, of course, reduce it. So 3 pi over 6 reduces into pi over 2. Then if we add another pi over 6 to that, we would get 4 pi over 6, which then becomes 2 pi over 3. Add another pi over 6, 4 pi over 6 plus pi over 6 is 5 pi over 6. And that doesn't reduce, so we'll just leave that on the line. Then 6 pi over 6, notice is equal to pi. 7 pi over 6 doesn't reduce. 8 pi over 6 would be equal to 4 pi over 3. And then down here we would have 9 pi over 6, which equals 3 pi over 2. And then 10 pi over 6, which is equal to 5 pi over 3. And then 11 pi over 6 doesn't reduce. And all the way around would then be 12 pi over 6, which, oh, look at that. That's equal to 2 pi all the way around our circle. So now we've done 30 degrees, or in radians, pi over 6 around our circle. And notice that all you have to do then is reduce those values to get the measures on the circle. And some of them we already knew. Halfway around the circle we knew was pi. And then all the way around the circle, 2 pi. And take half of pi, you get pi over 2. And then pi plus pi over 2 is 3 pi over 2. Just different things to know these values on your circle. And let's do the same thing with 45 degrees. So now if I do the same thing with 45 degrees times pi over 180, it's going to change it to a radian measure. So this would end up giving us pi over 4. So if we count around 45 degrees, 45 plus 45 is 90. Pi over 4 plus another pi over 4 is 2 pi over 4. And look, 2 pi over 4 equals pi over 2. And then this one would be 3 pi over 4, which doesn't reduce. Then 4 pi over 4, notice, is equal to pi. Then we would have 7 pi, or 5 pi over 4, not 7, sorry. 5 pi over 4. This is 6 pi over 4, which also equals 3 pi over 2. 7 pi over 4, and 8 pi over 4, which is equal to 2 pi. So you'll notice that these values, which are going to be very important later when we talk about our unit circle. So we just did the 45 degrees around, and notice that all of those were over 4. And a couple of other things to notice. Notice that if you look at this first quadrant, we have 1 over 6, 1 over 4, 1 over 3, 1 over 2. Then notice the next quadrant, 2 over 3, 3 over 4, 5 over 6. Notice the numerator is 1 less than the denominator. And then pi. And then the next quadrant, notice the numerator is 1 more than the denominator, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2. And the last quadrant, somebody had mentioned before, is 2 times denominator plus or minus 1. 2 times 3 is 6, minus 1 is 5. 2 times 4 is 8, minus 1 is 7. 2 times 6 is 12, minus 1 is 11. And knowing how to get these around your circle is going to be important. So that's something I would start practicing. Practice writing down your angles 30, 45, and 60 around the circle, and also practice writing your radian measures now that we've learned that. And that is all for the lesson for today. Just need to complete the homework.